This is a video that's going to give examples of adding resistors in series and parallel. So we have looked at just what that is and kind of a couple examples of cases that look like they're series but they're actually parallel and the other way around. But I want to do an example of this. So let's have a 12 volt battery and we'll add some resistors to this thing. I'm going to make each resistor be 2 ohms, and I'll number these things. 1, 2, 3, 4, 5. I would like to find the current running through the battery. So I want to look at this and see what I can figure out kind of right away. And what I see, I've got current running through my battery. It's going to go through resistor 1. And then it gets to this point, which is a junction. At that point the current splits and I've got some of it that goes up this way. I'm going to call that I23. And I've got some of it that goes down this way. And I'm going to call that I4. That current then comes back together. There's my I1. And I suppose if that's the current that goes through resistor 1 and through resistor 5, I can call that my I15, but my I15 also goes through the battery. So that is the current through my battery, which is the thing I'm trying to find. So then I'm just going to have to start working with these resistors and splitting up and combining what I can. So now I need to figure out how to combine these. Looking at this, and I'm going to erase not very much. Looking at this, I want to see how I can combine these different resistors in a way that makes sense, in a way that I can do something with it. I guess I am erasing a lot. So how do I do that? I'm going to say resistors 2 and 3 right here are in series with each other. I can see that because any current that goes through resistor 2 has to go through resistor 3. 2 is not directly in parallel with 4, but it mostly is. 2 is not directly in series with 1, because whatever goes through 1 is going to split 2 ways. So I would like to say 2 and 3 are in series with each other. Now if these are in series, then that means that their resistance must add. Which means R23 is R2 plus R3. 2 ohms plus 2 ohms equals 4 ohms. So I can redraw this circuit like this. And here's 1, 2, 3, 4, and 5. With R23 being 4 ohms. Now I'm going to look and I want to say 2, 3, and 4 are directly in parallel. Whatever goes through 2, 3 can't go through 4. Whatever goes through 4 can't go through 2 or 3. Or 2, 3, and there's the junction that combines them. So this is a parallel arrangement. If this is a parallel arrangement, then it's the conductance that adds. So G2, 3, 4 equals G23 plus G4. G23 is going to be 1/4. G4 is a half, and I get 3/4. R23 is going to be 1 over G, 2, 3, equals 4/3 ohms. So then I might redraw this. Sorry, this is 2, 3, 4. And here is R, 2, 3, 4 equals 4/3 ohms. Alright, this sort of a thing, and here's 5. This sort of thing comes up actually a lot on standardized tests. 1 and 5 look like they are drawn, or look like they're in parallel to each other because they're drawn parallel to each other. But they're not in parallel from like an electronic standpoint. From an electronic standpoint, we've got current that goes through 1. After it goes through 1, it goes through 2. After it goes through 2, or 2, 3, 4, it goes through 5, and then through the battery. These are all in series with each other. So all 3 of these are in series with each other. If they are in series, it's the resistance that adds. So R, it's all of them. So I'm going to say R total equals R1 plus R2, 3, 4 plus R5. So I get 2 ohms plus 4/3 ohms plus 2 ohms. I'm going to come denominator these. This is 4/3, 6/3. That makes 10 total thirds. Plus 6 more thirds is 16/3. So that's my total. I can combine this. I've got my battery, which is still 12 volts. I've got my total resistance. And then I am back to my battery. I can find the current running through my battery from using Ohm's law. So I have 12 volts over 16/3 ohms, or 12 volts times 3 over 16. And that's going to give me 9/4 ohms, or if you like, 2 1/4, not ohms, amps. 2 1/4 amps. So here is the whole problem start to finish. I tried to wrap that around onto one screen. I had this circuit to start with, and then I just said, let me find what I can get in pieces. These are in series, so I combined them in series. Then this and this are in parallel, combined them in parallel. Then everything was in series, combine them in series. And I guess this one I could say this way. I kind of did like this is in series with this and with that. Maybe it makes more sense to draw it that way, as in series. But that's the idea. I'm just finding what I can and breaking it into little manageable pieces. Once I've got the little manageable pieces, I can put those together into one cohesive idea, and then I'm done. I do want to do one more, because sometimes they don't look particularly clean. Sometimes we get a circuit that looks all kinds of goofy. sometimes we get a circuit that looks like this, and then there's a question of what is going on with this. So I want to show you how to get started with this. And the way that I do this, I start with my battery and I just start tracing around. So the first thing, I've got my battery, and then I like, after my battery, to just turn that corner. That way I know what I'm doing. I can kind of keep my battery in a separate location. So first thing I come across is resistor 1. And then I hit this junction. So a junction. After my junction, I can either go through 2. So let's go this way to 2. And if I go through 2, I keep going, turning the corner, doesn't change anything, there's not a junction, it's still the same current. So then I go through 3. And then I'm coming down and I hit a junction again. So hit a junction. Alright, what if I went the other way? If I went the other way, I would have gone not through 2, but through 4. And then I hit another junction. And it actually looks like the junction that I hit is the same for both of those. So I'm going to move this junction to a spot where these come together. After that junction, I keep going. I go through 5. And after 5, I'm back at my battery. This is exactly the same as this. Even though it didn't look like it, it's exactly the same circuit. So I don't actually need to go through the whole process again. I just wanted to show you how I can take a drawing like this one and turn it into something that's a format that I like a little bit better.